Next time you find yourself standing at a train station or watching a massive locomotive thunder past a crossing, take a moment to look down. Beneath those heavy steel rails and thick wooden ties, you'll find a constant, millions of rough, jagged gray stones stretching toward the horizon. Whether you are in India, the UK, or the United States, these stones are always there. But have you ever stopped to ask why? Why do we rest our most advanced high-speed machinery on a loose pile of rocks? Why not simply bolt the tracks to a solid concrete road? The answer isn't just about cost. It is a brilliant piece of engineering designed to prevent trains from sinking into the earth. It is a story that connects modern transportation to the ancient world of sailing ships. Welcome to Simple Things, Surprising Histories. Today, we uncover the hidden secret of the railway stones. To understand the stones, we must first understand the challenge. A loaded train is an immense burden, weighing millions of pounds. If that weight were placed directly on the soil, the pressure would crush the ground, causing the tracks to buckle and the train to derail. This is where track ballast comes in. Think of the railway as a layer cake. The steel rails sit on horizontal beams called sleepers, which in turn rest upon the ballast. The ballast acts as a vital cushion. It takes the concentrated weight of the train and distributes it across a wider surface area, protecting the ground beneath. Here's the fascinating part. The tracks aren't actually bolted to the earth. They are floating. They rely on friction and the sheer mass of the stones to stay in place. This flexibility allows the tracks to absorb vibrations rather than snapping under the intense tension of a moving train. You might wonder, why these specific stones? If you picked up a piece of ballast, you'd notice it's sharp and jagged. It might even hurt your hand. You will never see smooth, round pebbles on a track. There is a precise reason for this. Imagine walking on a floor covered in marbles. You'd slide everywhere. Smooth stones roll over one another. If a train passed over round rocks, the vibration would cause them to roll away, and the track would shift. Instead, engineers use crushed granite or quartzite. These angular shapes interlock like puzzle pieces. Their sharp edges bite into each other, creating a solid, immovable foundation that still offers enough flexibility to handle a high-speed train screaming around a curve. Beyond weight, these stones fight the two greatest enemies of the railway: water and vegetation. If tracks were laid on concrete or dirt, heavy rain would create mud or puddles, leading to erosion and rust. However, a stone bed is perfectly porous. It acts as a giant drainage system. Rainwater flows instantly through the gaps, keeping the foundation dry and stable. Furthermore, the thick layer of rock prevents a jungle from growing between the rails. Plants are dangerous. Their roots break up the soil and ruin the foundation. The stones serve as a weight bearer, a drain, and a weed killer all in one. Finally, there is the name itself. Why ballast? That term actually originated at sea. Centuries ago, empty wooden ships were too light to sail safely and would toss about in the waves. To stabilize them, sailors filled the hulls with heavy stones known as ballast. Upon reaching port to load cargo, they would dump these stones on the shore. Early railway engineers, looking for affordable, heavy material to stabilize their new tracks, saw these piles of discarded ship stones and realized they were perfect. They repurposed the ship's ballast for the rails, and the name stuck. So, the next time you see those jagged gray stones, remember, they aren't just rocks. They are a self-draining, weight-bearing engineering marvel that has kept our world moving for over 2 centuries. If you enjoyed this story, please like and subscribe for more insights hidden in plain sight. Thanks for watching.